Hello everyone, a very good evening all of you and a very warm welcome to you all to this wonderful session on fluid mechanics. In this session we will be discussing the most important previous year question for the engineering services examination. As you all know, in engineering services examination calculator is not allowed. That is one of the challenging aspect of this prelims paper. So you have to do even the lengthy calculation without using the calculator, correct to some extent. Even though you are not able to solve the equation correctly, at least you should be able to do it very much near to your correct answer, because the questions will all be MCQs. So you can easily find out the right option if you are able to do the calculation round off to the exact value. All right. So first of all, please do let me know if I'm properly audible and visible to all of you so that we can start our session. Those who are watching me live, can you guys hear me? Am I properly audible and visible? Even if you are not appearing for engineering services examination, the session is going to be very important for other competitive examination, because in most of the competitive examination like PSUs or engineering services examination, the questions are getting repeated. So if you are able to solve these type of questions, then it means you are very much comfortable with the concept. Hi Shreyas, good evening, welcome. Are you appearing for ESE 2024? So before I start, let me quickly introduce myself. Those who are watching me live, yes. What happened? Just hold on. Give me a moment. Yes. So please keep your pen and notebook and try to solve the questions on your own. And if you feel any difficulty, if you face any difficulty, you can always connect with me through the comment section. This is my quick introduction for those who are attending my session for the very first time. My name is Chandrasekhar. As I have already told you, I am mechanical engineering graduate from IIT Delhi. I have also cleared engineering services examination, worked in Steel Authority of India Limited for a couple of years, and from last 11 years I have been into teaching, guiding the students for various competitive examination, and fluid, thermal, heat transfer and industrial engineering are my favorite subjects. If you are not part of my Telegram channel yet, please you can join me on the Telegram, that is Mechanical by Chandrasekhar. The link is also there. Once you become part of my Telegram channel, you will be getting so many benefits if you are preparing for competitive examination, if you want to crack the competitive examination, and if you are aspiring for GATE 2025 on 21st of February at 7:30 p.m. your favorite Abhinav Negi sir will be taking a workshop. He is MTech from IIT Delhi, having more than 12 years of teaching experience. The workshop will be free of cost. You have to just register yourself to the workshop. The link is already there in the description box, and the session will be about 7 most important tips to clear the GATE 2025. And on the examination day, engineering services examination day, prelims, we will be live on the same day, giving you the analysis, complete detailed in-depth analysis of the examination, and what will be the best score, what will be the safe score if you want to be an engineering services officer. So this is number 1 question. This is very important question from the surface tension. Can you just give it a try? This question is asked so many times in engineering services. Not only in engineering services, this question had been asked in this PSUs also, BARC, ISRO, etc. So can you solve it? There is a spherical water drop of 1 mm in diameter. There is a single water drop. Let me call the radius to be capital R. So if the diameter is 1 mm, radius will be 0.5 millimeter. Isn't it? Do not commit these type of mistakes. Now it splits into 64 small drops of equal size. It gets splits into 64 small drops of equal size. The surface tension coefficient of the water in air, that is sigma, is given by 0.073. What is the work required in splitting up the drop? What will be the work required in splitting the drop? Yes. Can you give it a try? Now the question will be solved by another definition of surface tension. Force per unit length, that is Newton per meter. The unit of surface tension coefficient is Newton per meter. If we multiply and divide by meter, so it will become joule per meter square. So sigma can also be defined as the amount of work required per unit change in surface area of the liquid. This is how we can define the surface tension, joule per meter square. Right? So the question will be solved in 3 steps. First of all, we know sigma if we can find out the change in surface area. So how to calculate the change in surface area? For calculating the surface area for 64 droplets, we need to find out the radius small r of each and every drop. So the first step is the volume of the liquid remain constant. The volume of the liquid will be constant, isn't it? It means 4 by 3 pi into r cube is equal to 64 into 4 by 3 pi small r cube. The volume of the liquid will remain constant. So from here r is equal to capital R by 4. That is one step. Small r will be capital R by 4 because there are 64 small droplets of equal size. The single drop, whatever is the volume in the single drop, will be same as the volume in 64 drops. So the volume will remain constant. The radius of the smaller droplets is small r, right? So first is to find out the relation between small r and capital R. Capital R we know, we can easily find out small r. Then the second step is to find out the surface area in the first situation, that is 4 pi capital R square, and to find out the surface area in second case, because there are 64 droplets, into 4 pi r square, small r square, it will be small r square, and small r is equal to capital R by 4, so it will be 16 pi into r square, isn't it? So change in surface area will be equal to final surface area minus initial surface area, that is 16 minus 4 pi r square, isn't it? So that will be equal to 12 pi r square. That is the change in surface area. Yes. And once you find out the change in surface area, the last step is to find out work required is equal to sigma into change in surface area. Now do the calculation. 0.073 into 12 pi into r square. R is 0.5 into 10 to the power minus 3 whole square. So do the calculation, you will get the answer. So can you do the nearest calculation? What is 0.5 into 0.5? 0.25. So it will be 0.07 into 0.25 into 12 into 3.14 into 10 to the power minus 6 joule. Yes. This will be 0.0175 into 36 into 10 to the power minus 6. So how much is that? It will be 0.01. So it will be around, how much is the answer? So if you see the options, then 10 to the power minus 3, 10 to the power minus 3, 10 to the power minus 3 cannot be possible. A, B, D cannot be possible. It will be somewhere around 0.69 into 10 to the power minus 6 joule. 0.69 into 10 to the power minus 6 joule, isn't it? So if we assume it as 0.02, so it is around 0.02 into 36 into 10 to the power minus 6. How much is that? It is 0.72 into 10 to the power minus 6. It is somewhere around 0.72 into 10 to the power minus 6. That is very much close to 0.69 into 10 to the power minus 6. It will not be 10 to the power minus 3. Yes, Shreyas. C will be the correct answer. That is how you should be able to do the calculation appropriately. Even if you are not able to get the correct value, you should be able to do the calculation nearest to the correct answer. Yes. Question number 2. Again, the question had been asked multiple times. What is the intensity of pressure in the ocean? Very simple question. At a depth of 1500 meter. At a depth of 1500 meter. Assuming salt water is incompressible, rho is constant with a specific weight of, that is rho into g, gamma, 10,015 Newton per meter cube. The units, you should be able to observe the units. If you put SI unit, so according to hydrostatic law, P is equal to rho g into H. So that is 10050 into H is 1500. Isn't it? So how much is that? So if the options are in meganewton, 1 meganewton is equal to 10 to the power 6 Newton, isn't it? 1 meganewton is equal to 10 to the power 6 Newton. So if we find out 10 to the power 6, so it will be 1.0050 into 15 into 10 to the power 6 Newton per meter square, or 10 to the power 6 Newton is meganewton. So 15 into 1, it is around 15 meganewton per meter square. So option A is the correct answer, 15.08. Isn't it 15.08 meganewton per meter square? Yes, Shreyas. What about others? Everybody, please do share your answer. Try to solve them without using the calculator. That is the challenging thing. I hope this is clear. Question number 2. The question number 3. Sometimes you will find lengthy questions. So if you are not very much confident, you can skip those questions in the first attempt, and later on when you get time, then you can solve them. Third question is a little complicated. Question number 3. Question number 3 on the screen. Yes. Oil of specific gravity is 0.8. Acts on a vertical triangular area whose apex is in the oil surface. Apex means the vertex. The triangle is isosceles with 3 meter height and 4 meter wide. The triangle is isosceles with 4 meter wide and 3 meter height. And apex is in the oil. This is the oil. This is apex. A vertical rectangular area 2 meter high is attached like this. There is a rectangular area 2 meter high is attached to the 4 meter base of the triangle and is acted upon by water. So up to this point there is an oil and the remaining is water. This is water. This is water. What is the magnitude of the resultant hydrostatic force on the entire area? Now we need to calculate the hydrostatic force. The hydrostatic force on this area. Can you do it? Look, the diagram is something like this. Let us say G1 is the geometric center of the triangle and G2 is the geometric center of this rectangle. This is how the diagram is. There is an oil. Here there is an oil having specific gravity 0.8 and there is an water. Water specific gravity is 1. So we can say the force is equal to Pg1 into A1 plus Pg2 into A2. What is Pg1? What is Pg1? The gauge pressure at the free surface will be 0 according to, so this distance will be equal to 2 by 3 into 3, isn't it? Because the height is 3. This is 3 meter, this is 2 meter, this is 4 meter. So 2 by 3 into 3, that is equal to 2. So Pg1 is equal to rho of oil into G into 2. How much is that? And what about Pg2? Pressure at this point, average pressure. We are talking about, these are the average pressure. Whenever there are multiple fluids, we can go with the average pressure. Average pressure at 1, average pressure at 2. So that is how we will get the value. What is Pg2? That will be equal to rho of oil into G into 3 plus rho of water into G into this distance, that is 1, that is Pg2. And what is A1? A1 we all know, half into base into height. A2 is base into height. So F will be equal to, if we put the values, are you able to understand this? So F is equal to Pg1, that is rho of oil into G. Let us take GS 10. G is given as 9.81, but to keep our analysis simple, let us take GS 10. So it will be 800 into 10 into 2 into A1. That is equal to half into base, that is equal to 4 into height. This is 1 plus rho 800 into 10 into 3 plus 1000 into 10 into 1, then multiplied by 4 into 2. That will give you the answer. Can you do the calculation? This 2 getting cancelled out. So 8000 into 4 into 3. 96,000 plus how much is that? This is 24,000 plus 10,000. How much is that? 34,000 into 4 into 2. So how much is that? 96,000 plus answers are in kilonewton. So if we divide by 1000, so it will be in kilonewton. How much it will be? In kilonewton it will be 96 plus 34 into 4 into 2 kilonewton. Can you solve it? How much is that? 272. 372 minus 4. 368 kilonewton. It is somewhere around 368 kilonewton. Isn't it? It will be somewhere around 368 kilonewton. So B will be the correct answer. B will be the right answer. I hope you are able to understand this. This is wonderful question. Do you guys understand this? If anybody is having any doubt, beautiful question. Please do let me know. The next one, sometimes the question looks a little complicated, but it may not be that much complicated. Air flows through a duct and the pitot static tube measuring the velocity is attached to a differential manometer containing water. The pitot tube, like this, it is containing to the differential manometer which is containing water. The deflection of the manometer is 100 mm, like this. This will be the deflection of manometric fluid, that is water. Water is the manometric fluid, like this. So the manometric fluid deflection x is equal to 100 mm. X will be 100 mm. Assuming the density of air is constant and equal to 1.22 kg per meter cube. That is the density of air. That will be the density of air. And coefficient of the tube is 0.98. What is the air velocity? So velocity of air is equal to Cv into under root of 2g x into Sm by Sf minus 1. Isn't it? So that will be around Cv, let us take as 1. Cv, let us take as 1 into under root of 2 into 10 into x, 100 mm, that is 0.1 meter. Specific gravity of manometric fluid is 1000 upon 1.22 minus 1. So it is 1000 minus 1, 999. It is almost 1000. It is almost 1000. So 1 into under root of 2 into 10 into 0.1 is 1 into around 1000. So it will be under root of 2000. How much is that? 10 into root 20. Root 5. And what is root 5? What is the value of root 5? It is 2.23 something. So 20 into 2.23. So it is around 40. It is around 40. What is the answer? Isn't it 39.3? It is close to 40. It is close to 40. That is 39.3 will be the correct answer. I hope you understand this. Question number 5. Question number 5 on the screen. Again, wonderful question. Try to solve this. Water flows in a circular pipe. At one section, the diameter is 0.3 meter. That is, let us say D1. The static pressure, that is P1, is 260 kilopascal gauge. The velocity V1 is 3 meter per second. And elevation, that is Z1, is above the ground level. The elevation at a section downstream is 0 meter. That is Z2 is 0. And the pipe diameter, that is D2, is equal to, the question is from the Bernoulli equation, 0.15 meter. Frictional effects may be neglected. That means ideal flow. Assume the density of water to be 999 kg per meter cube. It is almost 1000. What is the gauge pressure at the downstream section? So P2 to be calculated. So if we apply the continuity equation, we can say A1 V1 is equal to A2 V2 is constant. That is Q. Or we can say D1 square into V1 is equal to D2 square into V2. So V2 will become, because D2 becomes half of D1. D2 is becoming half, 0.3 becomes 0.15. So V2 becomes 4 times of V1, isn't it? V2 will be 4 times of V1. Now if we apply the Bernoulli equation, let us write the Bernoulli equation in terms of pressure. So P1 plus rho g Z1 plus rho V1 square by 2 is equal to P2 plus rho g Z2 plus rho V2 square by 2. That is how we write the Bernoulli equation. Z2 is 0. So the objective is to find out P2. P2 is equal to P1 plus rho g Z1 minus rho by 2 V2 square minus V1 square. P1 is given as 260 kilopascal. So it will be 260 plus rho into G is around 10 into Z1. What is Z1? Z1 is 10. So it will be 100 kilopascal minus rho by 2, that is 1 by 2, 0.5 into V2 square minus V1 square. What is V2? V2 is 4V1. So it will be 16 V1 square minus V1 square, that is 15 into V1 square. And what is V1 square? V1 is 3. So it will be 9. That will be kilopascal. So it is 360 minus 135 divided by 2. What is 135 divided by 2? Something around this. So that is around 293 kilopascal, isn't it? Something around 293. So isn't it B is the right answer, 292.5. B will be the answer. So this is the simplest way of solving the questions. Question number 6, next one. Everyone, give it a try. Air moves over a 10-meter long flat plate. It means it is an external flow. It will be external flow. The transition from laminar to turbulent flow takes place between Reynolds number 2.5 into 10 to the power 6 and 3.6. So lower critical Reynolds number is 2.5 into 10 to the power 6. Between 2.5 into 10 to the power 6 and 3.6 into 10 to the power 6, the flow is, or the boundary layer is transitional. The free stream velocity is U infinity is this, and the kinematic viscosity. Hi Uday, welcome. The kinematic viscosity is 1.5 into 10 to the power minus 5 meter square per second. What is the maximum distance from the front edge of the plate along which one expects the laminar flow? So the flow will be something like this. Here the lower critical Reynolds number is 2.5 into 10 to the power 6. The upper Reynolds number, this is the lower, this is the upper critical Reynolds number is 3.6 into 10 to the power 6. Here the boundary layer is purely turbulent, here the boundary layer is purely laminar, and here there is a transitional. So if we want the boundary layer to be laminar or the flow to be laminar, so the critical value of Reynolds number is equal to 2.5 into 10 to the power 6 is equal to U infinity into critical value of X upon kinematic viscosity. The value, the question is to find out XCR. 2.5 into 10 to the power 6 into 1.5 into 10 to the power minus 5 upon U infinity. That is, what is the free stream velocity? 30. So it will be 10. So it will be 10 to the power 6 or 10 to the power minus 5 getting cancel out. So it will be 10 or it will be 3. 2.5 into 1.5 by 3. 2.5 into 1.5 divided by 3. How much is that? $3.75 divided by 3. 3.75 divided by 3. So it is greater than 1. So it is around 1.2. Isn't it 1.2 meter? It will be close to 1.2 meter. And the minimum distance, or the question could have been the minimum distance from the front edge of the plate along which one expects the turbulent flow. In that case, we should have used this value of Reynolds number. Right? Question number 7. The next one. A hollow cylinder of 0.6 meter diameter. A hollow cylinder of 0.6 meter diameter is 0.6, open at the top, contains some liquid and spins about its vertical axis. When it spins about vertical axis, it is an example of forced vortex. It is a question of forced vortex. Producing a forced vortex motion, it is already mentioned. What is the height of the vessel so that the liquid just reaches the top of the vessel and begin to uncover the base when it is rotating at 100 rpm. So this is the base. So it is about to uncover the base and it is touching at the top like this. This is how the shape of the paraboloid will be when omega or n is equal to 100 rpm. N is equal to 100 rpm. So this is ZP. This is R. So Z is equal to omega square R square by 2G. So ZP, which is equal to H, is equal to omega square R square by 2G. The question is to find out the height of the vessel, that is H. So H will be equal to omega 2 pi n by 60, 2 pi into n 100 by 60. A little bit of calculation will be required. Square into R square, 0.3 square upon 2 into 10 meter. So it will be something like this. So this will get cancelled out. So this will almost be cancelled out. So 10 square. So H will be equal to 100 into 0.09 upon 2 into 10. This will get cancelled out. This will become 5. So it is around 5 into 0.09. क्या आंसर आ रहा है? It is around 0.45. 0.45. Isn't it around 0.45? So the correct answer will be 0.503. The correct answer will be, it will not be 4.5 Shreyas. It will be 0.45. 5 into 0.09. It will be 0.45. So it will be, because we are taking G as 10 and pi we are taking almost 3. So that is how we are getting nearest answer as 0.45. That will be close to 0.5. Question number 8. The velocity of air at the outer edge of a tornado. Tornado is an example of free vortex. The velocity of air at the outer edge of the tornado, we can apply the Bernoulli principle. In case of free vortex, we can use Bernoulli principle. Where the pressure is 750 mm of mercury and the diameter is 30 meter, the velocity is at a diameter d1 30 meter and the velocity v1 is 12 meter per second. Considering the density of air to be constant and equal to 1.2, that is rho. Specific gravity of mercury is 13.6. What is the velocity of air at the radius of 2 meter? R2 is equal to 2 meter. Then what is the velocity v2? So for free vortex, torque is equal to d by dt, mvr is equal to 0, or we can say v into r is equal to constant. That is for free vortex. So V1 R1 is equal to V2 into R2. What is V1? 12. What is R1? 15 is equal to V2 unknown and to R2 is 2. So V2 is equal to 12 into 15 by 2 or 6 into 15 meter per second. 90 meter per second will be the answer. 90 meter per second will be the correct answer for this one. D will be the right answer. Isn't it? Well done. Good, 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 guys. Keep it up. The next question, again, beautiful one. The difference in the water surface level of two reservoirs which are connected by a siphon. Do you know what is a siphon? Meter. This pipe is called a siphon. Right? The length of the siphon is 600 meter, that is L, and its diameter D. If the siphon is running full, then what is the discharge from the siphon? We need to find out Q. Now, if we apply energy equation, friction factor is 0.02. So, if we apply energy equation between A and B, so we can say HA minus HB is equal to HL in siphon. HA minus HB is 8 meter. Siphon is FL Q square upon 12.1 D to the power 5. From here we can find out the value of Q. So Q is equal to under root of 12.1 into 8 into D to the power 5. What is the diameter of the siphon? 0.3 to the power 5 upon F 0.02 into length 600 meter. That is in meter cube per second. That will give you the answer. Can you do the calculation here? So 12 into 8. So it will be around under root of 12 into 8 into 3 to the power 5 upon 10 to the power 5 into 0.02 into 600, 6 into 2, something around 12. Isn't it? So this 12 getting cancelled out. So it will be around 3 square 9 into 2 under root of 2 into 3 6 upon 100 into root 2 root 10. Isn't it? Can you solve it? Let us try to solve it. So Q will be around 0.18 into under root of 6 by 10. Three by 5. So 0.18 into what is root 3? 1.732 upon what is root 5? That is 2.23. So it is close to 0.18. How much is the answer? It is how much is the, are you getting 1.139? How did you do the calculations, Riyaz? It is somewhere around 0.137. It will not be 1 point something, it will not be 2 point something, it will not be 3 point something. It will be 0 point something. Isn't it? 0 point something. right? D will be the answer. The next one, theoretical question. Question number 10. Find out the answer to the next one. Which one of the following is correct assumption for the derivation of Bernoulli equation? For the derivation of Bernoulli equation, it must be inviscid or frictionless or irrotational or non-viscous flow. The first assumption is inviscid, non-viscous, irrotational or frictionless flow. The second one is the flow must be steady. The third assumption is the flow must be incompressible. The fourth assumption is no heat and work transfer. There should not be any other form of energy transfer. And the fifth assumption is along the streamline. The equation must be written along the streamline or in tangential direction. Then we will get the energy conservation equation, which is known as Bernoulli equation. So the flow is unsteady, incorrect assumption. The flow is rotational, incorrect assumption. The flow is compressible, not correct assumption. So the viscosity must be 0. Viscosity must be 0, right? It should have 0 viscosity. If you guys are aware, let me tell you again that we have started a ground zero series for all the 5 branches for GATE 2025 aspirants on our Byjus exam prep app. If you have not downloaded the Byjus exam prep app, you can download it from the bit.ly link which is there in the description box, or you can go to the Google Play Store and download it. Once you install the app, you will be getting so many other sessions which we post-gate analysis sessions are also there on the Byjus app. Let us move to the next one, question number 11. Yes, solve question number 11. Water flows through a pipe of 200 mm in diameter and 60 meter length. You should take care of the units. Diameter is in millimeter, length is in meter, with a velocity of 2.5 meter per second. That is the velocity. What is the head loss due to friction using the Darcy formula? Very simple but important. Now the catch here is assume F is equal to 0.005. In the previous question, F was given as 0.02. When the value is very much close to, sometimes they do not mention whether it is a friction factor or friction coefficient. When the value of F is around 0.02, then it is friction factor. Friction factor F is around 0.02 or 0.032, and friction coefficient, there is another parameter that is called as friction coefficient. We use the notation F dash, is around 0.005. It is very less. So friction factor is equal to 4 times of friction coefficient. That is the relation. So if you see, this is given as, if you see the parameter which is given as is friction coefficient, that is what you need to take care with the values. They may not mention, they may use the same notation. That is the problem with the engineering services. But in GATE examination, you will get the value specifically whether it is a friction factor. But if it is a friction coefficient, it will be mentioned in the question. But in engineering services examination, they do not feel the need of mentioning, right? So what is the friction factor? Isn't it 0.02? So what is the head loss due to friction? HL, that is FL V square by 2GD. F is 0.02 into length is 60 meter. V square, velocity is 2.5 whole square upon 2 into 10, diameter is 0.2. So if you simplify this, this will get cancelled out. What is HL? That will give you 0.01, and that will be 6 by 20, 6 into 6.25 by 20, isn't it? (36 by 20). (18 by 10). It is 1.8 something. It will be something around 1.8. Is it 1.8? It will be greater than 1.8. Yes. It will not be 1.85. That is what you need to take care. Exact value you can find out. Here you can find out the exact value. So it will be 3 into 6.25 by 10. So 3 into 0.625. What is the value? (1.875). And because we have taken G as 10, G should have been taken as 9.81. If you take G as 9.81, so it will be greater than 1.875. So the correct answer will be D. It will not be option C. Do not commit this mistake. Always take care of the options which are very close to each other. So it will not be 1.85. It will be 1.91, which will give you the correct answer. Question number 12. Theoretical question. The pressure distribution in a liquid which is subjected to a constant horizontal acceleration. If the acceleration, horizontal acceleration is constant, then the free surface will be like this incline. So the pressure is P atm. And the constant pressure lines will be parallel to this. These are constant pressure lines like this. These are constant pressure lines. These will be the constant pressure lines. So for the horizontal acceleration, the pressure distribution is same as the hydrostatic pressure distribution. Yes, in the vertical plane, hydrostatic law is applicable. Less than the hydrostatic pressure distribution, more than the hydrostatic, equal to hydrostatic pressure distribution minus weight of the liquid. A will be the answer. A will be the correct answer for this one. Question number 12, A will be the answer. Question number 13. Simple question. A convergent mouthpiece. Mouthpiece is an instrument which is used to measure the flow rate. Is discharging water under a constant head of 5 meter. There is a tank and here there is a mouthpiece like this. The available head is 5 meter. And it is discharging water under a constant head of 5 meter. If the diameter of the mouthpiece is 75 mm, that is D, then what will be the discharge? Q is equal to area into velocity. Simple. Q is equal to pi by 4 D square into velocity. And what is velocity? From the Bernoulli equation, V is equal to under root of 2gh. So Q will be equal to pi by 4 into D square into under root of 2gh. That will give you the answer. So it is 3.14 by 4 into diameter square. What is diameter? 0.1 liter is equal to 10 to the power minus 3 meter cube. The units are in liter. 1 liter is equal to 10 to the power minus 3 meter cube per second. So it is 75 into 10 to the power minus 3 whole square. Little bit calculations is required. Otherwise the question is very simple. 2 into 10 into h, that is 5. That will be meter cube per second. So it will be around. Can you solve it? So this will be 10. So 10 into so in liter it will be 3.14 by 4 into 75 into 75 into 10 to the power minus 3 into 10 liter per second. So the answer will be, how much is that will be? Isn't it around 40.4? Sorry, 43.8. Please check, do the calculation. Do the calculation correctly. 10 to the power minus 2. So 3.14. So it is around, it will be around 3 by 4, 10 to the power minus 2. 75 into 75 is how much? So yes, panic. That is correct. 43.8. So 3 by 4. You must be getting 44.15, right? So because G is taken as 9.81, until and unless specified, we should take G as 9.81. Then we will get the answer. 43.8 liter per second. I hope you will be able to do. So 3 into 475 divided by 4. It is like this. Into 75 into 10 to the power minus 2 liter per second. $60 into 75 into 10 to the power minus 2. So it will be around 6 into 7.5. It will be something around 6 into 7.5 liter per second. 6 into 7.5. It will be around 45. Less than 6 into 75. So it will be less than 45. It will be slightly less than 45. So the answer will be 43.8. Right? Question number 14. Next one, a flat plate 1.5 meter by 1.5 meter. You should be able to do the calculation. That is the most challenging part. If you are very much comfortable with the calculation part, then you will definitely get a good rank, good score in the prelims paper. A flat plate which is having a dimension 1.5 by 1.5 meter moves at 45 km per hour. The unit is kilometer per hour in a stationary air of specific weight. This air, the specific weight gamma rho g 11.3. If the coefficient of the lift is 0.75, then what is the lift force? FL is equal to CL into projected area into rho u square by 2. That is the formula. And for a flat plate, for thin bodies, the projected area will be the same as the planform area. So coefficient of lift is 0.75. Projected area is 1.5 into 1.5 into rho into u square. What is rho? rho into G is 11.3, then what is the rho? That is 11.3 divided by 10. 11.3 divided by 10 into 2 into u square. The unit of velocity is 45 km per hour. So it will be 5 by 18 into 45 square in Newton. 1 kilometer per hour is equal to 5 by 18 meter per second, isn't it? 1 kilometer per hour will be 5 by 18 meter per second. Jack, are you using the calculator or doing the calculation without the calculator? The answer will be 151.9. The answer will be 151.9. Don't use the calculator. Why you are using the calculator? If the challenge is to solve without using the calculator, why you are using the calculator? Using the calculator, the question is very simple. But without using the calculator, it is a little difficult. Try to do the calculation without using the calculator. So it will be 0.75 into 225, 2.25 into 11.3 divided by 20 into how much is that? Twenty-five by 2. 25 by 2. Newton. That will be the answer. Yes, 625 by 4. Yes. Now do the calculation. Can you do it? This is something around 3. So this will be around 31. So it will be around 0.75 into 2.25 into 31 into 3. 91 Newton. So your answer will be near to 151.9. Question number 15. Again, the question is from the submerged body, a submarine which may be supposed to approximate a cylinder 3 meter in diameter and 50 meter long. The diameter of the submarine and the length is 15 meter, travels along submerged at 1.5 meter per second. The velocity is in seawater at 4 degrees Celsius. What is the drag exerted? So drag force will be equal to CD into projected area into rho u square by 2. Similar type of question. CD is 0.7 into projected area will be, the projection will be a rectangle. So 3 into 15 into rho, that is 1025 upon 2 into u square 1.54 square. That will be the drag force. Can you do the calculation? Find out the answer. It will be option D. If you will do the calculation, then your answer will be close to option D. D will be the correct answer. The next one, question number 16. What will be the answer for this one? Question number 16. If the pressure at a different section of the pipe are plotted to scale is vertical ordinates, the pressure on vertical ordinate and the flow is on x, then that will above the axis of the pipe, and these points are joined by sloping straight line. There is a straight line. So the straight line, the slope is dp by dx, which is constant. So which is known as, this line will be, straight line will be called as, it will be called as hydraulic gradient line. It will be called as hydraulic gradient line. It will not be total energy line. It will not be total head line. It will not be energy gradient line. The variation of pressure with flow is represented by hydraulic gradient line. So these are some of the questions which are most expected and most repeated. There are some more other questions also. I will share the PDF. And let us stop here. I was telling you about post-gate guidance session. The session had already been started from 13th of February. Tomorrow at 4:30 p.m. I will discuss the cutoff for IIT Roorkee. So do not forget to join me tomorrow at 4:30 p.m. But the sessions are on Byjus app. All right. And if you are interested to be part of our paid courses which are running for 2025 and 2026, you can join by calling the mentioned number, or if you want some guidance regarding the counseling, regarding the paid courses, you can either connect with the mentioned number, or you can fill the counseling form which is already there in the description box. Yes, Reyes, well done, good. So that is all from my side, guys. Thank you very much for joining in. I will see you in the next session. Till then, enjoy, take care, and do not forget to revise your fundamentals thoroughly before going for the engineering services examination. You will perform very well if your preparation is up to the mark, and if you have done the last moment revision nicely, then nobody can stop you from getting the good score. Try to get at least 60% in the prelims. If you are able to score more than 60% in the prelims, you will be able to get through the complete engineering services examination. All right. So with this note, let me take your leave. Stay safe, stay motivated, and all the very best for your examination. Take care and Jai Hind. Thank you very much, guys, once again.